If I let this play any longer, I'm gonna have a copyright strike, and this isn't good at all. So here is the tutorial. Let's start with the mountains. To add a mountain or to make a mountain in geometry nodes, we need a plane. Let's make this plane bigger, like for example 5, and let's add a geometry node workspace here, and let's start working on the mountain. So as you know, a mountain is basically a cone. So if I use the new graphics tablet my brother just got for his birthday, I can show you that a mountain should have a ground here and a ground on the other side, and it's gonna go up and down, right? The very basic shape of the mountain. If we now want to create a mountain like that, we have to have a value of 1 here, and it's gonna gradually decrease until it reaches 0. I was thinking the graphics tablet would make my handwriting better, but it actually seems to be making it worse. Anyways, we have to calculate the values like that. So as you know, in shaders, you sometimes have something like that, right? You calculate the object, you take the object vectors and you calculate their length, and then you have something that looks like that. And this is basically the exact inverse of what we want to do, because in the center here, you see it's 0, and it's going bigger and bigger on both sides, and also here and there. So we have to invert this. Now we just could multiply this by -1, and this would basically pretty much work, but I mean the 0 doesn't change into 1 here, because multiplying with -1 just gives 0 again. So what we can do is to subtract all these values from 1. So this means we subtracted nothing in the center here, because it is subtracting 0 here. And as it progresses outwards, we're going to subtract more and more. And if you make this number bigger, you have to subtract more until it reaches 0. So this is how we invert values like that, or gradients like that. We can do the same thing in geometry nodes, but instead of the object coordinates, we can use the position of all these points. So let's add geometry nodes and let's deal with this gradient. So let's add the attribute vector math. And as you saw, we need the length operation. So let's use the length operation, right? Length, and we have to calculate the length from the position of all these points here. Currently we have 4 points, and we're going to calculate the length of these points from the center. So position, and this will result in an attribute called, let's call this base mesh, right? Base mesh. Now you see we have some numbers here, and these are like nice and all, but we cannot visualize that. So to visualize, we need another attribute from vector math, and we have to add these numbers to the points. So let's add to the position of all these points the thing we just calculated by using an addition and resulting in the position, adding the base mesh. So right now we have something like that. Let's add more points so we can see what's going on here. Let's add a subdivision surface. And before geometry nodes, set it to simple, and let's add like, let's say 5 cuts here. And you see we have like something like that. This isn't a mountain, obviously. So first what we have to do is the same thing that we did in the shaders. We have to invert the gradient with the subtract node. So let's select the geometry nodes again, and let's invert it. So for that, you need a simple attribute math node, set it to subtract, and subtract from a float of 1 the base mesh, resulting back into the base mesh. And now it's inverted, and as you increase this, it's gonna go either higher or lower in position. Let's not touch this right now. So we have this thing here that is pointing in a totally different or a wrong direction. It should be pointing right down, and the reason why it is doing that is that, as you see, the base mesh attribute has single numbers, right? But the attribute vector math that displaces the plane needs a vector to work with. So it's currently taking all these numbers and like slamming them to the axes. So x is getting the same number, the y is getting the same number, and the z is also getting the same number. So what we need to do is to delete the x and y components and only keep the z. Let's use a attribute vector math node, and let's multiply the base mesh attribute with a vector. So as you see here, it's getting so dry here. As you see, we have taken the base mesh attribute and converted it to a vector type base mesh attribute, because here you see it is a float attribute, right? Base mesh float. And here, okay. And here it is also seemingly a float attribute, but it actually is a vector attribute because we have used the vector math node. Right. Yeah, you see here it has changed, right? It's base mesh vector. So it's pointing downwards, right? But the problem here is that the mountain is now progressing infinitely. So if I make this bigger, the mountain is just also going to be bigger, and this isn't anything very nice. So to fix that, we need a math operation called smooth maximum. So let's add this here. So set it to smooth maximum, and the attribute we're gonna change is the base mesh, and resulting also in the base mesh, because this is something we want to change. And you see something has happened here. We have a little mountain here in the middle. And if you change this to floats, you can probably understand better. So the first socket here, the base mesh attribute socket, is something that is like the basis of this operation. Then we have the result socket, which is like eventually the thing that is going to be written out from this attribute math node. And this one here is the distance or the level. I don't know what it's called actually. Anyways, it's going to raise or lower the plate right now like that. So let's set it to 0. And the C here is going to be the smoothness value. So if I make this mountain bigger with this subtract value here, let's put it like 3. Let's make it 4. 4. And if I increase this smoothness here, you see it's going to, or actually decrease. It's going to make the hard angle here a little bit smoother, and we can make it a lot smoother or a little bit smoother. Actually, 3 seems to be working better. So this is our mountain, right? This is the first step accomplished. Now let's add, I believe it's Shift or Command J. Yeah, it's Command J. So Command J, and let's call this the base shape, right? This is the base shape, and let's add some quick controls also. So we can add the height of the mountain, which is called the height. Then we can add the smoothness of the mountain, which is the C, so smoothness. Actually, we can also control the steepness of the mountain. So if we drag to the vector here in the attribute vector math and we increase it, it's going to be a little bit steeper, like a wizard hat right now. So let's put it like here. And also with these values here, we can tilt this mountain. I don't want to do that, but you might. So I'm going to keep them there. And let's call this steepness. So the mountain is looking pretty nice. And the next thing we have to do is to make sure that the mountain actually has some, graphics tablet is a little complicated stuff. Next thing is to make sure it has something like that, right? To do that, we're going to use some noise. It's pronounced noise, I believe. So let's go here and let's add an attribute sample texture, because this is the only way to use textures in geometry nodes. Attribute sample texture here. And let's add a new texture, which is going to be in the texture tab down here. And let's call this detail 1. So this is our first level of details. And the mapping down here is basically like with every texture. I mean, you need some texture coordinates. And in our case, we have already pre-made UV map here, the UV map. And we're going to use this in this mapping thing here. And the result is going to be an attribute called displacement. Could be anything you want, but I'm going to call it displacement. We cannot see anything right now. And this is logical because, I mean, we have the attribute, but we're not doing anything with it. So to do something with it, we're going to use the same technique as before. So we're going to add to the position of the points an attribute. So for that, we need an attribute vector math. And let's add to the position of the points the displacement attribute, and let's result back into the position attribute. And let's eat a strawberry to that. So right now nothing is changing, and this is because we don't have any texture actually. You see it's a blank black texture. So let's use clouds, and bam, we have some texturing going on here. It's a little low res, so I'm gonna add some subdivision like that, maybe even a bit more, right? So this is the thing here, and this is very weird because again we have the same problem. The displacement attribute is actually a vector attribute, and it's gonna like displace on every axis equally, but we only want this to happen on the z-axis. So to do that, what we need to do is to again grab an attribute vector math node and start the fixing process. So let's multiply the displacement attribute with a vector only on the z-axis. We have something a little bit normal here, not anything great. Because the problem is that, you know, the mountain should have the displacement going on only on the sides of the mountain, not on the ground. As you see, it's the case right now. As you remember, we have an attribute called the base mesh, which has the value of 0 down here and other values on the sides of the mountain. So we can multiply the base mesh attribute with the displacement attribute and basically have an attribute that is only having displacement values for the sides of the mountain, not on the ground, because it's going to be 0 there. So for that, let's use an attribute math nodes from here. And let's multiply the base mesh, the displacement attribute. Let's multiply the displacement attribute with the base mesh attribute, resulting back into the displacement attribute. And voila, as you see, we have displacement going on only on the mountain. And this is pretty nice, but it's not very strong. It's like, has some really, really smooth bumping going on there. So to make it stronger, we can increase this displacement multiplication here. So you see we are multiplying on the z-axis, but what if we multiplied more? So let's multiply more, and we have a mountain like that, right? Looking pretty extreme. We can decrease the height of the mountain. And actually, you mean this is the like section where we have to just play around with the values and see if anything works. This is a pretty nice thing, I'd say. Also, in the texture tab, actually, the clouds texture isn't a very nice texture, or it actually is, but the noise basis has to be something different. So as you see, Blender Original here, and we're gonna switch it to Voronoi F2, and it has done something like that. It's more like rocky, and this is better. So I'm gonna increase the scale or decrease the scale until it looks a bit better. And now let's go to the color section and let's add a color ramp here. So now you can increase the contrast of the texture. And this is starting to look like a mountain already, right? You just have to add some more details. So I'm gonna crank it to like 5 on the detail level and shade it smooth also. And this is like a pretty nice mountain already. So this is our first level of detail. I'm gonna make it a little bit more like flat in a sense. So I'm gonna add more of this height here, and this is the mountain. As you see, I have used too much color ramp because it is clipping. So I'm gonna drag down a little bit. Now we have to add the second level of detail. So for that, let's grab all of these and let's call those level 1. This is our detail level 1. Now we need our detail level 2. So for that, we need to use another attribute. So for that, we need to use another attribute sample texture. So let's duplicate this sample texture here and put it here, right? And this is currently the same texture, the detail 1, and it also is the same displacement attribute. Let's switch it to displacement 2, which is a new attribute that we're going to use afterwards. And let's press on this 2 here so that we have a new texture called detail 1001. Let's call this detail 2. Right, so in the texture tab, right now we have detail 2 and also detail 1. So the detail 2 isn't doing anything right now because we haven't used this to displace the points. So to actually make the detail 2 work, we have to use another attribute math node. So let's use an attribute math node, and let's add to the points, to the position of the points, again, the displacement 2, resulting back in position. And look at that, we have a lot of problems going on here. We have to fix them. So again, another attribute vector math node. multiplying the displacement 2 attribute with multiplying the displacement multiplying the displacement 2 attribute with a vector on the z-axis. So now it's displacing upwards again, the same thing we did here. And I'm also going to type 6 here, so it's the same power as before, which wasn't a cool idea probably. Anyways, yeah, let's put 1 back here again. And the next thing we're going to do is, what is it? We have to also make sure that the ground isn't being affected by the displacement 2 attribute. For that, we have a normal attribute math node, and we can multiply the displacement 2 attribute with our base mesh, just as we did here, and result back into displacement. This hasn't done anything. Oh yeah, we have to use displacement 2 here. So now it's fixed, and let's mute these nodes here right now. And let's see what it's doing. So it isn't doing too much here. Let's make it stronger. Let's use like 1 here. No, let's use 6 here. I don't know, I'm so like dizzy today. So it's doing something like that, but we need to use a really low res texture here. So my plan is to basically have the mountain like carved out, and we're just gonna add some points that are like some holes and abysses into the mountain, basically. I don't know if that's the right word, but we're gonna add some like lowercase places, basically. So here we have the attribute. Let's make this really contrasty with the color ramp under the texture tab. So we have something like that. And let's make the scale also bigger. Let's say something like that. Okay, now you see we don't have too much resolution, and these are the things we're gonna add or subtract from the original mountain. So right now we're adding. Without those, the mountain would look like that, pretty boring, but we're gonna add those, and we have some more irregularities, but we can also subtract them. So for example, we can do something like that, which isn't looking too good right now. So let's change the scale. Let's do some, oh, we have, okay, this is looking pretty nice actually. Maybe I'm just, I mean, if you're not happy with the amount going on here, you can go to the color ramp here and then change the color. For example, if you change the black, it's gonna do like that. If you change the white, it's gonna bring up these lower places. So this is how it works. I'm gonna keep it like that, and I'm also gonna add some more geometry so we can see how the mountain is looking right now. The mountain is looking like a mountain, and the strawberry did that. This was the last one actually. Now we're gonna add a material. So for this material, we're gonna go to the shading, delete all that crap I have here, and let's also delete these annotations. We don't need them anymore. So for the material, basically, you know, a mountain has rock and snow, and the snow is falling down from the sky, and the rock is just happens to be under the snow. If you have a snowy mountain, we're gonna have a snowy mountain. So for that, let's use the normal node, and let's plug the normal to the normal, and let's use the dot product output. Now, I made a video about dot product. If you want to know exactly what it's doing, I'm not going to explain like 100% here. This is basically giving us like which faces are facing towards the sky right now, or like you see, this means to the sky, and for example, this means under 90 degrees from this side, or from this side actually. So for example, if the snow would come from this direction, it would be covering all the faces on this side, and all the faces from here would be without snow. So we're gonna add a snow coming from the sky like that. And then we're gonna add another normal node and connect the normal to here again. And we're gonna multiply them together using a math. And this isn't like very useful right now, or it's actually pretty pointless because they're the same thing. But I'm gonna add another direction of snow like that. You can just choose what you like the best. For example, this looks pretty nice, I mean, so let's multiply them together, and we have a mountain like that. Now, this isn't very cool, so let's add a color ramp, and we have more control over the snow and the rock, and let's use this as the base color. So now the mountain is looking like that. This isn't very good because, you know, the rock is pretty like glossy and stuff, so we can use the same values to control the glossiness and also the bump of the mountain. So let's switch it to cycles actually, because I think it's gonna look better that way. I'm gonna use this HDR. No, it's too green. Basically, something like that looks okay. And we're gonna use the value here from the multiply as the value of roughness first. So let's drag it to roughness. And as you see, the rocks right now have the roughness of 0 and the snow has roughness of 1, which isn't correct at all. So to remap those, we need a color ramp. And let's make sure that the black values or the rocks are having the roughness of for about 0.7, 0.8, and the snow has something lower, for example 0.4 or 5. So this is looking a bit better, but what we need to do is to add something to the specular highlights. So again, let's track the value of the specular highlights, and snow is very specular, which means it's gonna reflect a lot. So right now it's pretty much correct, but the rocks aren't like so dim in the reflection sense. So we're gonna add the color ramp again, and let's make sure the rocks have the specularity of around 0.3, and the snow has specularity of 1, because it's basically like 100% reflective. Now also the base color isn't like true black for the rocks. It's gonna be something more natural, something like that. And the bump, because right now the rocks are very, very, very smooth. So let's use a bump node and let's plug it to the normal, and let's use a noise texture, because a noise texture is always a good choice for rocks and stuff. So use the noise texture, plug it to the height, and let's preview how it looks. It looks like that. Let's increase the scale a bit and some more detail like 6 and more roughness, so 0.8. This is more like a rock, and the bump looks like that. Pretty much like a mountain, right? And let's preview this. This is better, but the problem here is that the snow also has the bump. So to fix that, or to get rid of the bump on the snow, we have to use the same value again. So let's plug it to the strength of the bump. And right now this is inverted, so the snow has the bump and the rocks don't. So let's use a color ramp here. And what do we have to do? We have to make sure that first, of course, the rocks have the bump, and the snow might have a little bit of bump actually, or maybe just, let's make it 0. So this is the bump. And as you see, the snow is like, or the rock bump is very much like layers. So if you don't like layers like that, you can use different mapping from the texture coordinate node. So you can do some generated normal UV, whatever you decide to use here. So I do like these mountains, so I'm going to keep them that way. And actually I'm going to increase the contrast between the white and the black. So that's how the mountain is made. So as you see, you can control the amount of snow and the amount of rock procedurally. And this is basically how the whole thing works here. So if you're interested in the project file, this is available in Patreon, because now I do have Patreon, where I do a lot of stuff, for example, exclusive tutorials, full detailed tutorials, project files. From now on, the old ones will be available for free, but the new ones will be in Patreon. For example, in the full detailed tutorial of this mountain here, we are gonna bake the displacement map for this mountain alongside with all these additional explanations, full process, all that stuff. Patreon is a thing now, so you can check this out if you're interested. See you next time. Or on Patreon. This is a preferable choice.